Okay, in this video, we're going to be talking about a lab procedure called titration, specifically acid-base titration. This is something we'll have a chance to do a tiny little bit of in the lab. We're going to do actually what I call a mini titration because we're going to be working on a very small scale, but it still works using a similar principle. So the idea behind an acid-base titration is that it's basically just a stoichiometry experiment. We combine two substances in very precise amounts until the reaction reaches completion, so when it's finished. The substance that we don't know something about and we're trying to figure it out is called the analyte. This usually goes in the beaker, and then the substance that we know about completely is the titrant. This will usually either go in a burette if you're doing it on a large scale, or when we do it in the lab, we're going to do it with little droppers. And what we do is we just very slowly add the titrant in until the analyte completely reacts. Once you've hit the point where the reaction is complete, that's called equivalence. Now, it's kind of hard to determine equivalence in an acid-base reaction because all the solutions are clear and you don't get any noticeable sign once it's changed. The way that we work around that, though, is we use what's called an indicator. An indicator solution, and the one we're going to use is phenolphthalein, changes color at a certain pH. So at some pH levels, it's one color. At other pH levels, it's another color. So here's what we wind up using it for most commonly, a couple of different uses. The most common use of titration that you see is you make a solution and you want to know its exact concentration, so you titrate it to determine the exact concentration. Another way that you can use it is if you have some solid that you don't know what it is, you can identify its molar mass by using a titration experiment. We won't really get much into that one, but it is a fairly common use. Now, like I said, when you do a titration, we typically use an indicator. What you want to do is when you pick an indicator, pick one that changes color near the equivalence. So this is why we went over salt hydrolysis. We have to know whether strong or weak acids and bases, what the resulting salt is going to be, because that's the pH we're targeting with our indicator. So if we have a strong acid combined with a weak base, that's going to be an acidic salt, somewhere below 7. While phenolphthalein, which is the most common indicator we use, it's colorless in acidic solutions, but changes color to pink at around a pH of 8, is a really, really bad choice. Because the reaction's finished at 5, and then we have to keep adding more base after that to get the phenolphthalein to change. We would probably want to use something like methyl red, which is going to be red at a pH of below 5, but yellow at a pH above 5, orange at around 5. That indicator would probably be a much better one for this particular combination. And I'm going to ask you which indicator would be best for a certain reaction. Now, once we've done our titration and we've reached endpoint and we've measured how much of our titrant we needed to do that, the math behind titration is extremely straightforward. In fact, it's going to look like a formula that you've seen before. Just as a reminder, the number of moles of something in a solution is equal to its molarity times its volume in liters. Now, for any titration, which is a 1-to-1 reaction, which all the titrations I'm going to give you are 1-to-1, the formula that we're going to use is Ma times Va, so molarity of the acid times volume of the acid, will equal molarity of the base times volume of the base. If this equation looks familiar, it should, because this is basically just Boyle's law expressed with concentration. So instead of P1V1, we have Ma times Va. Same math, same calculation, really easy to work with. You just kind of have to pay attention a little bit to units, because sometimes you'll get volume in liters, sometimes you'll get it in milliliters. For our experiment, we're going to do it in drops. It doesn't matter what unit the volume is in for this equation, as long as they're both the same on each side. All right, so that's it for acid and base titration.